Okay, now that we know some basics about three-wire leveling, let's actually do a pretty in-depth example. I think doing one good example would be really helpful. So in this scenario, let's say you set up your instrument in 3 places and you took the measurements of 4 different points. Okay, we'll start at our BM, or our benchmark, our starting point. Remember, benchmarks are places where we know the elevation. And the benchmark or the elevation of this benchmark is 602.78 feet. Okay, and the question is asking, using points A and B, what is the elevation of point C? What's the elevation of point C? So on our little chart that I drew here, I put a column for the point, benchmark A, B, and C, then our backsite, our stadia check for our backsite, our foresight, our stadia check for our foresight, and our final elevation. Remember, the main difference between differential leveling and three-wire leveling was that instead of taking just one reading for the backsite, now you're taking 3. And because you're taking 3, you need to check if the stadias, or the half stadias of those 3 measurements are in check or are roughly the same. If they are, we can move on to the next measurement. So let's start here at A, or let me put down benchmark and say that its elevation is 602.78. Okay, so we take the backsite for benchmark for BM and we read. Remember, we're taking 3 readings, not 1. We take, oops, it's not writing. We take one here, and one here. And the top, middle, and bottom, respectively, I'm going to write down the backsides for the top, middle, and bottom are 5.92 feet, 4.46, and 3.01. Okay? The first thing you want to do is check your stadias. Let's assume K is 100. Okay? So the half stadia for top minus middle is 5.92 minus 4.46, which is 1.46, and if we multiply that by 100, we get 146. Okay? And the middle minus bottom, or 4.46 minus 3.01, is 145. Okay, remember, we're multiplying the half stadias by 100 because when we add them, we get the approximate horizontal distance from the instrument to our point, or the instrument to our benchmark, and I get about 291. Okay? That's the first step. The second step is you want to add these 3 measurements, the top, middle, and bottom. And when I add them, I get 13.39. Okay? Let's divide by 3 and make sure it's close to our middle reading, our 4.46. And if you divide 13.39 by 3, we get 4.46, which is actually very close to the middle, 4.46. Okay? So let's assume we took the readings, we checked the stadia, and now our average is matching the middle, so we can safely say that the backside for benchmark is 4.46. Let's do the same thing for the foresight. Okay? The foresight, or the reading at A, I measure out to be 5.24, 3.77, and 2.31. Okay? So I'm going to write that down here. For our foresight, we got 5.24, 3.77, and 2.31. Okay? Now let's add these just as we did. I'm sorry, let's check our stadia first. Remember, top minus middle, 5.24 minus 3.77 is 1.47. You multiply that by 100, you get 147. Remember, it's K times delta. Okay. And really you're just checking your horizontal distances, making sure your stadias are the same, and making sure your horizontal distance from the instrument to the backside and the instrument to the foresight is somewhat the same. Now our 3.7, or our middle minus the bottom, or 3.77 minus 2.31 is 1.46. Multiply that by 100, you get 146. Let's add these together. You get 293. You can see that the horizontal distance from the instrument to the foresight is 293, and the horizontal distance from the instrument to the backside is 291. So they're roughly the same. Horizontal distance, pretty good. Now, let's go back to our foresight. Let's average these. You add them all together, you get 11.32. You divide by 3, you get 3.77. Now, remember from differential leveling, what you do to the elevation to find elevation A, you take the previous elevation, you add the foresight, and you subtract, you add the backside and you subtract the foresight. So 602.78 plus 4.46 minus 3.77 gives us the elevation of, elevation of point A. And the elevation of point A is when you add 4.46 minus 3.77 to the 602.78, you get 603.47. Okay? That's the elevation of point A. Now, let's keep going. Now you move your instrument to this point. You move your instrument from here, and you go here. And you take the backside, so you sight from the instrument to rod at A, and the measurements you get for that are, let's say they're 7.81, okay, 7.81, 6.41, 5.01, okay. Let's check the stadia. 7.81 minus 6.41 is 1.4 times 100 is 140. And then the same thing here. Middle minus bottom times 100 is also 140. You add this together, you get about 280. Okay? For the foresight, so when you sight the instrument from here, or you sight from here to here, and you read the top, middle, and bottom, you get 3.12, 1.71, 0.32. Let's check the stadia. Top minus middle times 100 is 141. Middle minus bottom times 100 is 139. You add these together, you actually get 280. In this case, our horizontal distance are exactly the same. That's even better. Here, our stadia is off by a little bit, but not by much, so we can assume that it's okay. So, let's go to our backside. Let's add these together. You get 19.23. You divide by 3, and you get 6.41. Okay? Same thing for the foresight. You add these, and you get 5.15, You divide that by 3, you get 1.72. Okay? So, to find the elevation of point B, you take the previous elevation, you add the foresight, you add the backside, and you subtract the foresight. So 603.47 minus 6.41, 603.47 plus 6.41 minus 1.72, you get an elevation of 608.16 feet. Why I wrote that in the blank column, I'm not sure. This actually goes here. Now, let's do this process one more time. So you take the instrument from here, you move it here, you take the backside, and you take the foresight. And the backside readings, your top, middle, and bottom, you get 6.86, 5.04, 3.20. Remember, this is for the back sight. So you're at this point and you're backsighting to B, and you read the top, middle, and bottom, and you get these numbers. For the foresight, you're at this instrument and you foresight to C, and you read the top, middle, and bottom for those. You get 4.46, 2.62, 0.79. Let's go to the backside first. Let's check our stadia. 6.86 minus 5.04 times 100, you get 182. Middle minus bottom times 100, you get 184. Roughly the same, it's okay. You add this together, you get 366. Same thing for the foresight. For top minus middle times 100, you get 184. And the middle minus the bottom times 100, you get 183. You add these together, it's 367. Okay? So the horizontal distances are roughly the same, and the stadias are checking out to be good. Our backsight, let's take the average just as we did the last two. You take these three numbers, you sum, or you take the sum of them, you get 15.10. Divide by 3, you get 5.03. Same thing for the foresight. Take these numbers, add them, you get 7.87. Divide by 3, and you get 2.62. Okay? So, to find the elevation of point C, you take the previous elevation, you add the backsight, and you subtract the foresight. So 608.16 plus 5.03 minus 2.62 is 610.57. Okay? And this is the elevation of point C using 3-wire leveling. Now, just remember to always check the stadia intervals before averaging these numbers. If your stadia interval came out to be significantly different, your half stadias, you may want to go back and remeasure or recite whatever point you were citing and take the measurements again. Okay? So that was an example using 3-wire leveling.